In this session, I will be solving a few important problems of pair of linear equations in two variables. Before I begin the session, I would like to tell you that it's very important you keep your textbook, either hard copy or the soft copy, along with a notebook and a pen. Then you can just jot down all the important points. It's very important because the only way to learn mathematics is to do mathematics. And in this, while solving these problems, I will be doing up to the level of getting equations in case of word problems, and in case of numerical problems, some complicated ones, some different problems I will be solving. In this exercise 3.3, up to third problem, they are quite normal, except that in second problem you need to take LCM and change the equation. Say in second problem we have s minus t is equal to 3, and the second equation is s by 3 plus t by 2 equals 6. So here you get fractions. So what you have to do here is take LCM of 3 and 2. Okay, LCM of 3 and 2 is 6. Multiply every equation by LCM of 3 and 2. So we know LCM of 3 and 2 is equal to 6. So this 6 will be a multiplying factor of this. So 6 times s by 3 plus 6 times t by 2 equals 6 times 6. Every term is multiplied. So here the equation changes to 2s plus 3t equals 36. Okay. So this is, and you have, this is your equation 1 and this is equation 2. So you have your two equations to solve. Now, in case of fourth problem, which is 0.2x plus 0.3y equals 1.3. Another equation is 0.4 plus 0.55 equals 2.3. See, every term is having one place after decimal. If you notice, every term is uniform here, one place after decimal. So we have to multiply both the equations by 10. When we say multiply the equation by 10 or whatever number, you have to multiply every term by 10. So now 10 times 0.3 is 2x plus 10 times 0.3 is 3y equals 1.3 times 10 is 13. Similarly, we get 4x plus 5y equals 23. So equation 1, equation 2. You have both the equations and then you can solve for x and y using substitution method. Now I will move on to the fifth problem. Root 2x plus root 3y equals 0. Another equation is root 3x minus root 8y equals 0. You can take any of the equations since this is negative, and when you transpose it becomes easier. So I will first express this root 8 as 2 root 2y equals 0. Transpose root 3x is equal to 2 root 2y. X is equal to 2 root 2 by root 3y. So this should be substituted in equation 2. In equation 1, sorry. Root 2x plus root 3y equals 0. So what is x for us? 2 root 2 by 3 y. Right? X is whole thing. X is 2 root 2 by root 3 y plus root 3 y equals 0. So what happens here? Take y as common. You get 2 times 2 by root 3 plus 3 equals 0. Y is equal to 0. Put this y is equal to 0 in this equation. Let's call this equation. This is equation 1, equation 2. Let's call this equation 3. So, x is equal to 2 root 2 by root 3 times 0. X is equal to 0. So, our values are finally x is equal to 0, y is equal to 0. Right? And the sixth problem. I will move on to sixth problem. Just have a look at these problems once. X by 2 minus 5y by 3 equals minus 2. X by 3 plus y by 2 equals 13 by 6. So, as we have seen in the second equation of the second problem, right, we have denominators and we need to bring them to standard form. So, as I told before, take LCM of 2 and 3, which is 6. So, multiply both the equations by 6. So, let's take this equation 6 times 3x by 2 minus 5y by 3 equals minus 2 times 6. Right? So, here what happens? 6 times, I will just take them separately. It's easier for us to solve. 2, 3. So, 3 3s are 9x minus 2 5s are 10y equals minus 12. This is equation 3. Next, take this. Same thing, multiply every term of this equation by 6 as LCM of 3 and 2, 6. Y by 2 equals 6 times 13 by 6. 3 so 3 2. So it is 2x plus 3y equals 30. Right? This is equation 4. Now these two are our equations 2. I'll rewrite the equations which look just like any other equation divided by 2x plus 3y equals 30. So you have to solve for x and y using substitution method. You can use these two as your pair of equations to solve by using substitution method. Next. Now we will move on to the word problems of third main. The first problem of the third main says the difference between two numbers is 26 and one number is 3 times the other. Find them. So here, first you should understand what is it that we need to find. When you read the problem, you will understand that you need to find the two numbers, the difference of which two will be 26. Such two numbers we have to find. So, from the last part of the question, we should be able to assume what is it that we need to find. So, let's assume, let one number be x, let the second number be y. Okay, because we are talking about two numbers here, right? And here, why I wrote this first is, instead of writing like this, you should say, see, if you understand, they have given that the difference between the two numbers is 26. It's a positive number. Right? So, if you have to get a positive number after subtraction, then smaller number must be subtracted from larger number, right? So here, instead of writing let one number be, we can write let the larger number be x. Isn't it? Now we can say, therefore we can write x minus y is equal to 26. Okay? We already got one equation, right? And from the remaining part of the sum, let's see how we can derive the second equation. It says that one number is 3 times the other number. That means larger number is 3 times the other number. Which is the larger number here? X. Okay. Now you write this. Okay. Larger number is 3 times the other number. Let me clear the board. Larger number is 3 times the other number. This is case 2. That means for our second equation. Right? This is our case 1. We get first equation. This is equation 1. The larger number is 3 times the other number. That's what is the given information. Larger number, which is our larger number? Larger number is x. Is, as I told you in my previous sessions, is, was, will be, should be written as equals. 3 times the other number is what? Y. So, x is equal to 3y. Now, you already have the second equation ready in the form which can be substituted here. X is equal to 3y. So, what we can do? Substitute equation 2 in equation 1, or you can say substitute value of x in equation 1. So our equation 1 is this: x minus y is equal to 26. What is x for us now? 3y. 3y minus y is equal to 26. 2y is equal to 26. Y is equal to 13. You want y value? Now, substitute this in this equation. Shall we call this as equation 3? Okay. Now, x is equal to 3 times y value. What did we get? 13. Put this here. 13. What is x now? 39. See, we got the values. X is equal to 39 and y is equal to 13. And verify your answer by substituting it in the equation, in the given word problem. And the problem says the difference between the two numbers is 26, right? That means you check exercise 3.3, third problem. Let me read the problem once. The coach of a cricket team buys 7 bats and 6 balls for rupees 3,800. Later, she buys 3 bats and 5 balls for rupees 1,750. Find the cost of each bat and each ball. So, if you see the last part of the question, it says, find the cost of each ball and each bat. That should tell us what to assume. So, first we should assume let the cost of each bat be x and let the cost of each ball be y. So, we will say let the cost of each bat be x. Let the cost of each ball be y. Right? So, we have x and y. Now, how do we get this first equation? What is this? Case 1. We call this case 1. What do they say? There are 7 bats and he buys 6 balls. He buys all this. Okay. Now, Actually, he has paid 3,800 rupees is the total cost. Okay. Now, if each bat is X rupees and he buys 7 bats, so what will be the total cost that he has paid for the bats? It is 7 times X is the total cost he has paid for bat. Similarly, cost of each ball is Y and he buys 6 balls. So totally 6Y. 6Y. See, we got this equation, right? Equation 1. Our assumption remains same for both the equations. Okay, this applies to both. Now, what is the total amount that he has paid in this second case? 1,750. And how many bats he has purchased? 3 bats. What is the cost of each bat? X rupees. And how many balls did she purchase? She purchased 5 balls. What is the cost of each ball? Y. Beautiful. 3x plus 5y is equal to 1,750. When you solve for x and y, you should be very, very careful when you write your conclusion statement. When you write, and it's compulsory for you to write the conclusion statement. Whatever value you get for x, and here don't forget to write properly. As soon as you get your x value on solving, you just say bat. Here x, as soon as you get y value, you say y. And then in the conclusion, remember to write, therefore, cost of each bat is, which value will you write? X value. Similarly, cost of each ball is, what value will you write? Y value. Because our assumption, bat cost is X, ball cost is Y. This is clear now? Third problem. Check this once again. Let's solve third main fourth problem of exercise 3.3. This is a very interesting problem. The taxi charges in a city consist of fixed charge together with charge for the distance covered. For a distance of 10 km, the charge paid is rupees 105, and for a journey of 15 km, the charge paid is rupees 155. What are the fixed charges and the charge per kilometer? Now I repeat this question again. What are the fixed charges and charge per kilometer? That means they are asking us to find two types of charges. So that tells us one should be X, one should be Y in our assumption. How much does a person have to pay for traveling a distance of 25 km? So once you find these two charges, you can calculate the charge paid for any kilometers traveled. So what do we assume? Like how we discussed before, you see the question what you are asked to find. You are asked to find fixed charges and charge per kilometer. Yes. So our assumption should be, let the fixed charge be X rupees per X rupees. Fixed charge. Let charge per kilometer be rupees Y. Yes, I will explain to you what this is. See, whenever we travel by a cab or auto, every city will have its own standards, rules. The bigger the city, the distance fixed will be smaller. Okay, let's assume in a place X, in a place A, the fixed charge, once you get into an auto, they say minimum is 20 rupees. Okay, let us say up to 3 kilometers, it's 20 rupees. Beyond that, whatever you travel, you must have noticed in auto rickshaws, after some time, the meter starts running, right? When does the meter start running? it starts running after we finish the fixed charge distance. Okay, for example, let us say in a city, the fixed charge is for about 3 kilometers. Let us say they charge minimum 20 rupees. Okay, so when you sit in an auto rickshaw, up to you travel 3 kilometers, the meter will not change. It will be like that only. That means up to that distance, 20 rupees is fixed. Okay, even if you get down at 2 kilometers, you still have to pay 20 rupees only because that is fixed charge. After 3 kilometers, what happens? Let us say person R gets down after 5 kilometers and person S gets down after 7 kilometers. Now up to 3 kilometers, both will pay 20 rupees, right? And the person R will pay for 2 more kilometers extra, whereas person S pays for 3 more kilometers extra that he has traveled. Here what happens? Now person R, if the charge per kilometer is 5 rupees, okay? Charge per kilometer is 5 rupees. What was the fixed charge? Example again, 20 rupees. 20, 20 fixed for the first 3 kilometers. Next, he travels 5 kilometers. That means after 3 kilometers, he has traveled 2 kilometers extra, right? And charge per kilometer is 5 rupees. So 5 plus 5, 10 rupees. 20 plus 10, he has to pay 30. Now the second person S, 20 rupees is fixed. After that, he has traveled 3 kilometers extra. So that for that extra, he is paying 15 rupees. So 20 plus 15, he pays 35 rupees. Okay. So he pays 35 rupees. Now I hope you understood. So now let's adopt this in solving this problem. Case 1, let's see what is the information given for case 1. In case 1, the distance covered is 10 kilometers and the total charges paid is 105 rupees. Okay, which means this 105 is including the fixed charge and the variable charge. We know the fixed charge is X plus Y. How many kilometers traveled? 10 kilometers at the rate of Y rupees per kilometer, and that gives us 105. You understood? Fixed charge plus 10 kilometers at the rate of Y rupees per kilometer means 10Y. This is the variable, total variable charges he has paid. Case 2. Case 2, what is 15 kilometers? Traveled is 15 kilometers and the amount paid is 155. Okay. So, fixed charge will not change. X plus 15 kilometers per kilometer Y rupees. For 15 kilometers, 15 Y rupees. And the total charges he paid was 155. Equation 1, equation 2. Solve for equation 1 and 2. Solve for X and Y. You will get X value. You will get Y value. Okay. And you are supposed to find the total cost for traveling 25 kilometers. 25 kilometers. See? 10 kilometers X plus 10Y. 15 kilometers X plus 15Y. 25 kilometers X plus 25Y. Find the cost because here you would have found X value, Y value. Substitute, you will get cost for traveling 25 kilometers is equal to X plus 25Y. Fixed charge for 25 kilometers. You will get the answer. Next, let's solve fifth problem of exercise 3.3. a fraction becomes 9 by 12 if 2 is added to both the numerator and the denominator. So if you read it from the other way around, if 2 is added to both numerator and denominator, the fraction will become 9 by 11. If 3 is added to both numerator and the denominator, it becomes 5 by 6. Find the fraction. See, wherever there is find the whatever part, that from that you should get the clue what you should assume. So find the fraction. That means you have to assume let the fraction be x by y, because we're talking about fraction, x by y, right? That means numerator is x and denominator is y. Okay, case 1. What does it say? If now in this problem, remember, use this as a standard method. Okay, whatever may be the condition, x long line y, easy to find. Now, what does it say? If you add 2 to the numerator and the denominator, the fraction becomes 9 by 11. Clear? Okay. Now, cross multiply. You get this. Always remember, it's a very, very important tip for you to keep in mind. Always close this with brackets. Close this with brackets. Compulsory. Now, 11x plus 22 equals 9y plus 18. So, bring everything. Bring the variables to one side. Minus 9y and bring the constant here. It becomes, which is already there, plus 18. Write that first and then transpose the other side number. So, this is 11x minus 9y is equal to minus 4. Equation 1. Case 2. See, as I told you in the beginning session itself, in this lesson, our first aim is to derive two equations into variables. Case 2. As I told before, very important tip. Before you apply any conditions, keep this ready. Keep this ready. Next, 3 is added to numerator and denominator. And they say the fraction becomes 5 by 6. And then what is it that we have to do? Immediately brackets. Very important. Then cross multiply. 6 times x plus 3 equals 5 times y plus 3. So we get 6x plus 18 equals 5y plus 15. As I told you before, transpose all the variables to one side. 5y equals 15 minus this comes here 18. 6x minus 5y is equal to minus equation 2. Solve for x and y. You should get the value of the fraction. Then finally you should conclude it by saying therefore required fraction. Therefore the required fraction is x by y. Should write x and y value here. Your x, y. Put the values in this place. This is compulsory. Therefore, the required fraction is, and then you should substitute the values. Now let's solve problem 6. 5 years hence means 5 years from now. That means after 5 years. That's what it means. 5 years hence, the age of Jacob will be 3 times that of his son. 5 years ago, Jacob's age was 7 times that of his son. What are their present ages? Okay, let's begin. As I told you in the beginning session, whenever you come across these problems related to ages, problems related to ages. Means I'm not talking about diabetes, blood pressure and all such problems related to old age. So this is problems related to ages, I'd say. Okay, so what we have to do here? Present age, then dash years later. Very easy to understand. You have to do it like this. Dash years ago or before. These kind of words will be used. Dash years later, or as we have seen here, hence, from now, these kind of words. Okay. Now let's see. Now you have to find their present ages. So what do we understand by this? It tells us what to assume. So what do we have to assume now? We have to assume their ages. That means let one person's age be X, the other person's age be Y. Okay, and there again you should understand. Now 5 years hence the age of Jacob will be 3 times that of his son. Here Jacob's age in this statement is depending on the value what we get for his son's age. Right? That means Jacob's answer value will be dependent variable. Son's will be independent variable. Okay. So it's always better X should be independent variable. Okay. So let us begin. Let X be son's age. Son's age. Let Y be Jacob's age. Jacob's age. Now, how many years before? How many years hence? Both the side. They have talked about 5 years hence, and they have also talked about 5 years before. Now, first let us get the general statements of 5 years before and 5 years later. So, 5 years. If he is 6 years now, 5 years ago, son was X minus 5. Jacob was Y minus 5. Now, generally, after 5 years, son will be X plus 5. Jacob will be Y plus 5. Very simple. Now he is X. 5 years ago he was X minus 5. 5 years later he will be X plus 5. Same thing. Y minus 5. Y plus 5. Now let us start applying the conditions here. Okay. So if you solve one condition, you will get case 1, case 2, you will get 2 equations. What do they say? 5 years hence, as I told you before, first write in simple words, Jacob will be 3 times his son's age. 3 times his son's age. So what have I told you before? Jacob's age. Because I am writing all in this column now. In this column. Jacob. I plus 5. As was will be. Everything is equal sign in mathematics. Okay? 3 times. What is son's age? X plus 5. You will get one equation. So it is y plus 5 equals 3x plus 15. So let's bring everything to one side. Here 3x minus y plus 15 minus 5. 3x minus y plus 10. Okay. So you got the equation. Equation is 3x minus y plus 10. Equation 1. Next, let us see what the other condition is. Jacob's age was, okay, Jacob's age was, what has been given? 7 times. 7 times his son's age. So how do we write? Jacob's age, what is Jacob's age? This side, y minus 5. Was means equal sign. 7 times sun's age, x minus 5. Here, see, simplify, you will get another equation, 35. So you have 7x minus 35 minus y plus 5 equals 0. So you have 7x minus 35, 7x minus y minus 30 equals 0. Equation 2. This is equation 1. So here, if you solve for equation 1 and 2, this pair of these equations for x and y, you will get sun's age and Jacob's age. You should be very cautious when you are writing the conclusion statement. Therefore, Jacob's age, present age of Jacob is, which value will you take? Y value. Because here we have assumed that Jacob's age is Y, right? And Jacob's son's age is which value? X value. Because we have assumed son's age as X. Clear? Fine. So this is how you have to write the conclusion.